Hey class, today what we're going to look at is graphing exponential functions. Um, so what we're going to do is we're going to look at kind of all the shifts, horizontal shifts, vertical shifts of the exponential function and kind of how that relates to the parent function. So the parent function that we're going to look at today is f of x equals 2 raised to the x power. It is implied that there's a 1 there, so if you think back to our normal regular exponential equation, y equals a times r raised to the x. So what we're looking at is a, remember that's our initial term, so that would be a 1, and then r is the common ratio, which is 2, which is what we multiply by each time. So I would start at 1, do 1, 2, 4, 8, 16. And so what we're going to do is take our x values that we have over here, sub them into my equation, and get our values. So if I did subbed in a 4, that'd be 2 to the 4th, which would be 2 times 2 times 2 times 2, and 2 to the 4th is 16. And then we just keep going, 2 to the 3rd, so this would be 2 to the 4th, 2 to the 3rd, which would be 8, and then 4 to, remember anything raised to the 0 power is 1. Now whenever we get to the negative numbers, remember that is 2 to the negative 1. Remember that makes it a fraction, so then that makes it 1/2. And then this becomes 1/4, 1/8, and 1/16. If you can see that down there. So it's kind of the reverse of this. If you notice our pattern up here, it's the same pattern, but it's just in our denominator, there's a 1 in our numerator. So that's what happens whenever you have that negative in the exponent. It makes it a fraction, makes it the reciprocal of that number. So let's graph these. I'm going to start at 0. I know that at 0 it's 1. So that is my y-intercept. And if you think back to when we talk about this, our initial term is usually our y-intercept unless you have shifted it somehow. But normally whatever this term is, if we haven't moved it at all, if we haven't shifted it, will be whatever a is. So a is 1, then I know that at 1 it's equal to 2. So I'm just plotting my ordered pairs. So think of this is my x, these are my y's. So I got 2, 4, so I go over 2, up 4. And then I go 3, 8. 3, 8, about right there. And then 16 is like up here. So we'll make that point. And then this is like a negative 1, it's a half, and then a 4th, and then an 8th, and then a 16th. So if you notice, it gets really, really small, but it never actually touches 0. And just kind of for future reference, that would be called an asymptote, is if you have a line that gets really, really close to a number, but doesn't actually touch it. So our final graph will look something like this. We get our J curve that we've been talking about for a while. And it looks like a J, so that represents an exponential function. And so what this is going to be is this is going to be our parent function. So now we're going to learn about how to shift that function around. So I've got y equals 2 to the x. Remember, that's my parent function. But what I'm going to do is I'm going to subtract 5. So all of my points that I did have earlier, I'm now going to subtract 5. So if I think of, I got to the negative 3, I had 1/8, so then I would just subtract 5 from that, or you can put it into your calculator. And the easy way to do that, you go, so you would press 2, and then this button is what's going to be your exponent. So I'm going to raise it to the x, which I said was negative 3. So I've got 2 to the negative 3. In order to get out of the exponent, because I want to make this minus 5, I'm going to press over. That gets me out of my exponent, and then minus 5, and so then hit that. It gives me negative 4.875. So then I could just put this down, negative 4.875. And then we could do the same thing. So one of the cool things about your calculator is if you want to redo the same function but just change one number, we can just press second. So you press second and then enter. Brings up exactly, and then we can go edit it. So I'm going to change that negative 2 or negative 3 to a negative 2. Hit enter. And so now you see we got negative 4.75. And if you continue that, that would be negative 4.5. This ends up being negative 4. This is negative 3. This is negative 1, and then 3. So then if I were to plot these points on my graph, let's see here. I'm going to start at 0, got negative 4, and then I know that at 1 it's here, and then negative 3, negative 1, and then positive 3. So what you should notice is it looks very similar to what we've done up here, but what you should notice is that this point, if you look at it, we've moved it down 5 points, and if you look at this, we've got minus 5. So what change occurred? We shifted the graph down 5 points. All right, so we're going to do kind of the same thing here, but now the minus 5 is in our exponent. So we need to do that. So I'm going to go back to my calculator. I'm going to do 2 raised to the negative 3. But now, instead of shifting down, instead of getting out of there, I'm going to leave it in my exponent. If you have a TI-83, just put it in parentheses. And so you see that we have a really small number. So 0.0039. I'm rounding it, of course. So I press my second enter, plug that back in. And my number is 0.0078 and negative 1. Got 0.015. We'll round that 1/6. At 0. 0.03. 0.0625. If you notice, there's kind of a trend that all these numbers are really small, but they're starting to grow. So this one would be 0.25. So what's happened is, at negative 3, it's really small. So got all these really, really small numbers at 0, at 0.3, so that's still really small. Now if it continued, that would be, my next point would be 0.5, and then I'd get 1, and then I would get 2, and then 4. And then we'd end up getting the same J-curve. And what's happened is, now we've shifted this graph 5 to the right. So our change that has happened is 5 to the right. Okay, so same kind of thing. We're now adding 3 each time. So we plug in my points. I'm going to kind of speed this up. If we were to add 3, I'm going to shift my points up. If you were to plot all these points, it ends up looking like that. And so what's happened is, now we've gone up 3. And then over here, look here, what's going to happen is 1, 2, 3. I know my graph is a little bit off, but what's happened here is this is now left. So if you put in your points and plotted all those, you would see that that ends up being shifting it that way. So let's get some generalizations for my graphs. So if I were to shift it to the right, so I think about my original equation, y equals a times r to the x power. But remember, if I'm shifting it to the right, remember the last one we added 3 and it went 3 to the left, and whenever I subtracted it went to the right. So if I subtract a k, or actually let's call that h for horizontal. So if I subtracted a h, it's going to move to the right. If I move it to the left, it's going to be all the exact same, except for I'm going to add h. So remember, adding goes to the left, subtracting in your exponent moves it to the right. Here, if we were to move it up, and this is outside of the function, we're going to move it up, so you're adding whatever your k is, and then we're subtracting k here. So if it's moving down, you're subtracting outside. So just like we did our shifts with our lines and all that stuff, you'll start seeing a pattern for all of our graphs, that this is the way that stuff shifts as we look at our parent graph versus our transformations.